Okay, so our next set of speakers are Addie Dove and Ryan Watkins, and they will be talking to us about the Lunar Surface Science Workshop, Dust and Regoliths, and so providing a recap of that really exciting workshop. I got to participate in that, and it was fantastic. So, yeah, take it away, Addie and Ryan.
Thanks, Jorge. I will go ahead and start. So yes, we just have a recap today, as you mentioned, of this great workshop that was had back in August of 2020. And this is one of the sequence of Lunar Surface Science workshops. Ryan and I were the session moderators, but it was organized by a great group of people, and we had some amazing facilitators that helped us through the workshop. And the recordings of the meeting are available. You can see the link there, and we can post it in the chat after this as well. So the purpose and scope of the workshop, obviously, as in the title, was to discuss dust and regolith on the lunar surface. And one of the things we tried to do during this was to sort of define what we meant by dust versus regolith. It's a nice spectrum of things, obviously, but we tried to sort of define it for the purpose of the workshop and then in the report. And so the nomenclature we use really, we tried to relate to the characteristics and the phenomenology of the particles that we were talking about, and how those resulted in interactions with both human and robotic systems. So loosely, we define dust as the finest particulates, and the phenomena then relate to lofting and blowing of dust. And then for this, dust mitigation is the key technology area. On the other hand, regolith, again loosely, is sort of the general characteristics of the material as it's on the surface, which is really important for doing science on the surface of the moon. And this is then tied to key technology areas of mobility, trafficability, sample acquisition, and things like that.
Yeah, so we covered a few different topics in the few hours that we spent chatting. We went through programmatic concerns regarding dust from different divisions within NASA. We had a few speakers give their perspective from the Apollo program and the issues with dust that were experienced for those missions. We also had one presentation from one of the HLS contenders, Dynetics, talking about their human systems and some of the approaches they're taking to mitigate dust. And then we kind of broke the rest of the talks down into two sections. One was a scientific understanding of the characteristics of dust and regolith, and then proposed instruments to actually measure or mitigate these effects. And then we had two breakout sessions, which we'll kind of highlight in a few slides. The first being dust and mitigation, specifically the dust phenomena, different strategies for mitigating dust, and then the second was regolith characteristics and different implications for sample acquisition and trafficability.
Hey Ryan, your audio is breaking up a little bit, so I don't know if maybe whether it's the connection or something. So if you want to check that, thanks.
It's probably my connection. It's been a little spotty. I'll see if I can fix something here real quick.
Okay, yeah, I'll jump back in. And similar to a lot of how some of these other workshops are being done and how the workshop will be today, we have these breakout sessions in which we sort of discussed what had been presented and some of the questions that had been presented by the speakers, and we'll talk about that here in a minute. And these really figure out some of the status of questions, such as what has already been addressed, what are we working on, and what have we not started to tackle. And remember, this was all the way back in August, so some of these questions that we had we've been starting to tackle those, and there's been open calls for some of the things addressing these topics even since then. The presentation information, discussions, and the chat were all captured for a final report that we put together that summarizes some of the science questions and some of the priorities for these missions. And that report is available at the link below. And again, we'll put that in the chat. And there is an open discussion available on that site as well. And you'll note also that all of the LSSW workshops are putting together these reports, and so they're all available at this website with the different themes listed. So we wanted to then discuss a little bit about some of these outstanding questions we found, and so we broke it down based on sort of the breakout sessions. So one of the first things we looked at was, what are the dust phenomena, and then strategies for mitigation. So the questions brought up by some of our speakers and in some of the discussion were, what are the processes and mechanisms that control the transport and dynamics of lunar surface dust? And then sort of grouped in the classifications of surface modification by bombardment and other mechanisms. And so how does that affect the dust on the surface? And how does it produce dust on the surface? And how does it move it around? And then there's another sort of grouping, which is electrostatic or magnetic dust behavior. So this is, what are the actual properties of the dust, and how does the lunar surface environment play a role in shaping the dust itself, but also moving dust around? How does this all relate to the natural environment and to any modifications that are going to be made by the presence of robotic or human activity? One of the super interesting scientific regions, obviously, on the moon is in magnetic anomalies. And so those are going to be very different, potentially active dust environments. So those are of particular interest. So what some of the strategies then for mitigation that we talked about, or different types of strategies we might look at for dust mitigation, would be, how do we leverage existing efforts to actually do some science? So there's obviously a lot of interest right now in dust mitigation, and a lot of that is technology driven, but how can we also leverage that to do some interesting science and learn about the physics of the moon? But then also more practical questions of, like, what simulants should you be using when testing? What things like particle size, composition make a difference? And then what technologies and techniques are needed to really look at this dust mitigation problem? And then there's a sort of a different classification, which are dust and human interactions. So how does the lunar regolith behave during human-induced interactions? This is everything from landing to surface operations to just sort of having a presence of things on the surface. And then what are things like particle size distribution, composition, potential toxicity of lunar dust that are going to be important to better understand, especially for particles less than 50 microns. And this is driven by biological concerns. And then there was a good question, which was, what would you travel to the moon if your good health could not be guaranteed? And this is good health related to dust specifically. So obviously then from our discussion and from our summary, and this is captured a little bit more in the report, but characterization is very necessary. So there's a lot of work that needs to be done to understand how we can do dust mitigation and these things, but also just characterizing the surface is going to be very important. And so this should drive some of the early mission goals in terms of, how do we actually understand what the materials are on the surface better, and how they're different at different locations, and how they interact with humans and robotic presence. So one instance on here is, what's the presence of ice? So the polar regions might have very different behavior than equatorial regions. And I mentioned magnetic anomalies, right? So there's all these different regions that might have very different effects. And again, what simulants are appropriate to use for these things. And this brought more discussion then to sort of the technological aspects of what approaches should be used to look at techniques for not only mitigation, but maybe understanding the spectrum of avoidance, right? So there could just be dust exclusion. So you try to avoid getting anything in at all. Mitigation is where you have some of these things, but you try to get rid of it. And then tolerance is, okay, how tolerant will your systems be to dust? If you have optics, can you take some level of dust coating? Things like that. So designing systems that are dust tolerant, and sort of working with knowing the system and also what your capabilities are, and trying to make them as robust as possible. And a big conclusion was that it's going to take a lot of experience on the lunar surface to understand this better, and returning samples that have been on the surface as well.
Thanks, Addie. Thanks for kind of carrying us there for a minute while I fix my connection issues.
No problem.
Yeah, and so I know Addie just went through questions and discussion related to dust. So we also had several that came up related to regolith, and I won't go through all these here, but you can see them listed. And these were kind of questions that some of our speakers highlighted as key things that need to be answered for future exploration. Things like how do volatiles migrate through the regolith? What is the 3D microstructure of undisturbed regolith, and how are these structures different, if they are at all, in permanently shadowed areas? We had some discussion on the processes by which impacts continually shape the regolith, and then how large of an area is actually affected by a newly formed impact. You can go to the next slide. Lots of discussion on space weathering as it was relating to regolith, especially at the poles. So how does space weathering actually manifest itself at the poles? Is it different than equatorial regions? How important are things like micrometeorite bombardment and solar wind ion exposure in the optical space weathering of the surface? Again, what are the dominant space weathering processes for the moon? How does the presence of volatiles and the temperature affect these processes? So again, you kind of see a theme here, a lot of questions related specifically to polar regions, which have been previously unexplored. And then is there a unifying model of space weathering that can connect all of the airless bodies? Go ahead and go to the next slide. Then we had some discussion on actual system designs and trafficability. So like how do we design our science systems and procedures to collect regolith grains in as pristine of a state as possible. So I had some interesting discussion about different ways you could go about doing that. And then how does surface pristinity affect the fidelity of engineering tests? Like what makes lunar grains stick, and how does this affect our mechanisms? How does the regolith actually behave during human-induced interactions, whether this be, during descent and landing, or roving, or different things that involve humans. And then here you see our question that kept coming up of, would you actually travel to the moon if your good health could not be guaranteed? All right, next slide.
Okay, we have about 1 minute left.
Okay, I think we're pretty much almost done here. During our breakout session, we had some good discussion on some of these topics a little deeper, again, in terms of space weathering at the poles and the potential for KPLO to possibly image this and answer some of these questions. Extensive discussion on fairy castle structures, kind of on the micro scale, like how do we measure these? How do they affect our remote sensing data and our understanding of polar regions? And how do we address questions related to porosity of regolith? Next slide. And again, just more discussions on regolith sampling. Can we have automated coring? Do we need deeper cores? Is trenching more useful? Is rock coring more useful? And then trafficability, how do the geotechnical properties of PSRs differ from equatorial regions or regions where we've had astronauts before? Is ice an issue, and just how can we navigate efficiently on the lunar surface? I don't know if we have another slide or if that was the last one.
That's our last one.
All right. Yep. So there's kind of a brief summary, and like Addie's probably already mentioned, you can check out the report for a lot more details on the things we mentioned here. We actually had some more breakout sessions at the league meeting, so we kind of expanded on some of these topics even further.
Okay, great. Well, thank you so much, Eddie and Ryan, for the fantastic recap of the lunar surface science